Welcome back, friends. Today we are going to discuss the LeetCode problem 198, house robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So we have been given an array of integers, and so let's just take this one of the examples here. So these are the houses, like as you can see, like zeroth house has a amount of money, let's say $2, then first house has a $7, then second house has a $9, so on, so we have to uh, rob all these houses in such a way that we'll get maximum money, and the constraint is that we cannot rob the two adjacent houses. That is the important thing, right? Otherwise it will contact the police, like the adjacent house we cannot rob. So we can solve this problem by using a dynamic programming approach. How What we can do is, like let's say, like if let's say we want to rob, we want to start like the robbing from this zeroth house, right? So maximum money we can get from the zeroth house if we are robbing is 2, right? So 2 is the maximum money we can get. Now, if we go to the first house, then we can compare these two, right? What is the maximum? That's what we will drop. So if we are on the second house, we'll see that 7 is the maximum here. So we'll try to drop 7. So we will say that DP of 1 is 7. So we will put 7 as into DP of 1. Now, when we go on to the second house, which is actually like you can say like third house, right? But on the array index, it is the second house. So in that case, what we will do is we will try to like compare how much we will get the money if we connect the zeroth house and the second house, right? Because we cannot connect to the first house because it is adjacent to 9, so we can connect to the zeroth house because zeroth house is not adjacent to the second house. So the amount of money we can get is 11, 9 plus 2, right? And if we get the amount of money we can get from the first house is 7, so we are trying to get the maximum amount, right? So we will just put the 11 here when we are robbing the second house. So similarly we will continue, so if we are going on the third house, then again like we will try to compare the third house, means the we are here third house, and we will compare with the first house, right? We can combine these 3 and 7, so the maximum amount we are getting here is 10, right? So if we are combining 3 and 1, then 7 plus 3 is 10. That's what we can get. But if we are on this previous house, we already have gotten 11 here on the second house. So we will take the maximum from these, right? So we will compare 10 and 11 and we will take the maximum. So as of now we got 11 because 11 is the maximum. So if we go to 6, then we will try to compare the 6 with the previous possible maximum robbery, right? So maximum house what that we can rob. So this is the maximum amount that we can add into this 6, right? So 6 plus 11 is equal to 17 here. So 17 is the maximum when we reach here, because if you compare with the previous house, this is the previous house for the 4, so amount we got is 10, so we will not take 10, we will actually we will just add the 11 plus 6 and we'll get 17, so we will take the maximum as 17. So similarly we will go to the last house, which is a 4 house, so we will compare this 4 and we will try to add it to the previous possible house, which is 10, right? 10 plus 4 is 14, so 14 is still smaller than 17, right? So 17 is the maximum amount we can get into the previous house here. so we will try to keep the 17. So the maximum amount we can rob at the end of the house is the 17. So that is what the answer we can find. So this is the DP implementation that I have it here. I created just nums dot length is total as a n, and then I created a DP array from nums dot length, and the DP of 0 is nums of 0, right? Because that is the maximum we can get from the first house. When we go to the second house, means DP of 1 basically, because array starts with a 0, right? So we will compare with 0 and 1, and then we will populate whatever is maximum amount into DP of 1. And going forward, from 2 to the end, like 2 to the end of the houses, we will just use this method. We will either can take the amount from the previous house, which is I minus 1, or we can combine our current house amount with the I minus 2 amount, right? Because we cannot take the adjacent house, otherwise it will inform the police. That is what the condition they said here. So that's how we will populate the DP of I here, and at the end we will just return the last house, which is DP of n minus 1. So I took the first example that they gave us. This is the first one that they gave us, and this is the one to this is the one that we discussed here. So let's just run this code quickly. So as you can see, the 4 is also correct and the 17 is also correct. So both are correct. So let's submit this solution. Yeah, this is some problem I think with the LeetCode. Let me try one more time. DP of 1 is equal to nums of 0 and nums of 1. Yeah, let me just take a look into this quickly, because oh, so I think we have to first check with this condition. So if we can just say nums dot length is equal to 1 and nums of 0 is equal to 0, then in that case we will just return nums of 0, right? So that's how we can do that. So I think this should fix it. Yeah, so let's try this. Yeah, oh, we don't have to do this actually. If whenever there is only one element, we just want to just return the same element. Think, sorry about that. Yeah, so the solution works. It is 100% on the runtime, and memory usage also better 6%. So this is how we can solve the like this LeetCode problem using house robber using a dynamic programming. So these are the kind of a boundary conditions we have to account it, because the LeetCode will like they will uh, run different kind of test cases, so we have to make sure it works for all the test cases. So I hope you enjoyed this video. If you like this solution, please click subscribe to my channel and hit the like button and click on the bell icon so you get notifications for any of my future videos. Thanks for watching.